Just about every car guy gets to a point where he's got to bend some brake line. If you want to buy it, you can go to Classic Tube. Now, there's a lot more technology involved in actually creating something like this than you might think. So we visited with those guys and had them show us how they do it. The brake tube production process usually starts in one of two ways. A proper set of engineering blueprints can give the tube engineers all the data they need to create a CNC program for a piece of tubing that will be created on an automated bending machine. The other and only option in some cases, such as when pieces need to be reproduced from badly worn originals or very rare pieces, is to use a CMM, or a coordinate measuring machine. After mounting the piece to be reproduced, the CMM will use a non-contact probe that will be passed over the tube at 2 points on each straight. Then the CMM calculates the X, Y, and Z coordinates and create a computerized version of the piece. This data is then sent to a CNC machine that'll bend the first sample. Now that sample is subjected to a thorough quality control process to ensure that all of the production run pieces meet the high level of performance that both Classic Tube and all of their customers expect. The brake tubing itself comes in 4 basic types. Stainless steel is most popular. For the restorer that wants the 100% concourse correct look, a tin Bundy weld or TBW tubing is used, or green Galfin tubing. Copper-clad is another form of tube that's used in some rare cars and was actually OEM on older Ferraris. The first step in creating a production piece is cutting the long raw tubing into the correct length. Now, during the cutting process, the tube is burred slightly, so a grinding wheel is used to deburr the ends on the outside diameter. A special bit is used to deburr the inside diameter of the tube. Now, at this point, the tubes will be subjected to an end-forming process called flaring. There are many ways to flare the end of a tube, but there are 2 methods that are clearly most common. Depending on the final use, the tube may receive an ISO flare, which is created via a single strike process. This is also known as a bubble flare and is typically used on import applications. The second type is a double inverted flare, and this is created using a double strike hydraulic end forming machine. This piece is generally used in braking systems, but again, it's got other applications as well. The fittings that go onto the lines during the flaring process are produced in many different colors. This is because during the original OE installation process, different colors are represented in different thread pitch and pitch values. All this allows for easier identification and installation. State-of-the-art computer-controlled programmable tube benders then take the prepared tube with fittings and start the bending process. Using data from either the blueprints or the CMM machine, the CNC bender will manipulate the tube through all points on the X, Y, and Z axes. This process can be applied to pieces that range from just a few inches long to lines that can run several feet. Bends can be performed on various diameters of tubes, whether they be brake line, fuel line, or transmission line. Certain rare pieces can be so long that the automated bender may not be able to manipulate the final few inches of the bend, so then it's down to the experienced and skilled manual benders, and they'll take it over to finish off the piece. Armor guard is applied at strategic points on some pieces to protect them from harsh conditions and to prevent premature wear.